And welcome back, students. Today we're going to be discussing another thing in programming an array, which is that of enumerated types. So getting started. Sometimes you need a simple type consisting of a short list of named values. For example, the values might be clothing sizes, days of the week, or some other brief list. Now, Java allows us to have such an enumerated type. So, for example, the following is enumerated type for the days of a 5-day work week. Enum work day, Monday, Tuesday, Wednesday, Thursday, Friday. A value of an enumerated type is a type of named constant. So by convention, it's spelled with all uppercase because it's a constant. Remember, whenever we do a constant, it's all uppercase. So if we use, for example, Monday, not Monday, in the above definition of the enumerated type workday. Now, technically, if we had used Monday spelled out normally instead of all uppercase, that would be legal, but it's considered poor programming style. As with any other type, you can also have variables of an enumerated type. So workday, meeting day, available day. A variable of an enumerated type can have a value that must either be one of the values listed in the definition of the type, or else the special value null, which serves as a placeholder indicating that the variable has no real value. So for example, you can set the value of a variable of an enumerated type with an assignment statement as follows. Meeting day is equal to workday.Thursday. Note that when you write the value of an enumerated type, you need to preface the name of the value, such as Thursday, with the name of the type. So, for example, workday.Thursday, not just Thursday. As an enumerated type, you can combine the declaration of the variable with the assignment of the value to the variable. Workday meeting day is equal to workday.Thursday. A program that demonstrates the syntax for using enumerated types is given in enum demo. So let me just flop over here. And you can see here, I have enum workday, Monday, Tuesday, Wednesday, Thursday, Friday. Here's my method. Workday start day is equal to workday.Monday. Workday end day is equal to workday.Friday. System.println workday starts on start day. And system.println work ends on end day. And even though, yes, you could technically do this with, just by coding in a variable for, Monday or Tuesday. This is a real easy, basic example just to kind of drive home how enumerated types work. Do you always need an enumerated type? No, but it can be something very handy to have. Now, be sure to notice that when we created the enumerated types, we placed the definition of them outside of the main method in the same place that we normally give named constants. So if you notice, it was right here, right before our public static void main. Now, if I want to output an enum, we can output that using just our good old friend println. So, for example, system.println workday.Thursday will produce the following output on the screen: Thursday. You'll note that the type name workday is not an output. Now, other examples of an enumerated type are given in the enum demo, as we showed here. All right, so we could easily just, for example, right here was workday.Friday, and so then output it end day. All right, let's talk about some numeric comparison. The values of a numeric type, such as workday.Thursday, are not string values. Right? Even though they look like strings here, they're actually not. In fact, you should not care what kind of values here they are. So enumerated types aren't necessarily tied to one value or another. How they are implemented is not relevant to being able to use the values of an enumerated type. All you really need to know that, for example, workday.Thursday and workday.Friday are different values and will test as being different if you compare them with equals to equals. In other words, they will have different places in the system memory. Although values of a enumerated type are not string values, they are used for tasks that could be done by string values. However, enumerated types work better than strings for some tasks. So even though a lot of times we will use strings for most of what we do, enumerated types actually have some advantages. Now, you could use a string variable in place of variable of an enumerated type. So, for example, I could say string meeting day equals Thursday instead of workday meeting day equals workday.Thursday. Kind of already mentioned this earlier in saying we could just use a string, but we're using this for a very basic example here. However, using a string variable allows for the possibility of setting the variable equal to a nonsense value, such as Sunday or Gaga for workday, and to do so without the computer issuing a warning statement. So if I had, like, let's say, string, first day is equal to Monday, That's great, but later the program could come along and say string first day is equal to worst day, anything like that. It'd be very simple to change that. However, when it's enumerated, because it's a constant, there's nothing I can do in the program to go and change that enum value. With a enumerated type, you know only the possible values for a variable of that type are the values given in the enumerated type definition. If you tried to give the variable a different value, you're going to get an error message. Now, an enumerated type is actually a class, and its values are therefore objects of the class. So when we compare two variables or constants of an enumerated type, we can use the equals method, but it's far more common to use the equals operator, because we're not actually necessarily having to worry about what's in them. We just have to check the memory reference. So if meeting day equals available day, system.println, meeting will be on schedule. If meeting day equals workday.thursday, system.println, long weekend. With enumerated types, the equals method and equals operator are equivalent. But obviously, it's a lot easier just to put the double equal sign, and so therefore it's a little bit nicer syntax. So if we're comparing two enum values, just use equals. All right, cycling through values, to get the full potential from an enumerated type, you need some way to cycle through all of its values. The static method values provides you that ability. This method returns an array whose elements are the values of the enumerated type, and is provided automatically for every enumerated type. Now, the enum values demo gives a simple example of using the method values to cycle through all the values in an enumerated type. So if we look at this one, you can see we again have our workday here, but now I'm creating workday days, workday.values. All right, then here it says scan queue with new system scanner in, double hours is 0, sum 0. It's creating a for loop here, so it's going to cycle with this for loop, enter hours work for the day, hours equals keyboard.next double, sum equals sum plus hours. Total hours worked plus sum. All right, so if we run that one real quick, just to show you. Enter hours worked for Monday, let's put 4, Tuesday, let's put 3, let's do 6 hours for Wednesday, 5 for Thursday, and how about 4 for Friday? And you see it says that we work 22.0 hours. Now this is one situation where it's much cleaner technically to use a for each loop instead of an ordinary for loop. Right, so we could actually go through and rewrite this for loop here using a for each. All right, let's just quickly discuss some methods of enumerated types. So there's the public Boolean equals method, which returns true if the argument is the same as the calling value. And while it's perfectly legal to use equals, it is easier and more common to use equals. All right, we've already discussed this. And there's a quick example, value 1 dot equals value 2, which is the same as value 1 equals value 2. Public string toString, which of course recalls the calling value as a string. This is often invoked automatically, so you don't have to put out toString. This happens a lot when we're doing our enumerated types using system.out.println, or when we're concatenating the value to a string. So for example, workday.monday.toString will return Monday. Public int ordinal, which returns the position of the calling value in the list of enumerated type values. The first position is 0. So it's kind of treating it like it's an index. So first position is 0, followed by 1, 2, 3, etc. All right, so that's why workday.monday.ordinal will return 0. Public int compared to any value of the enumerated type returns a negative value if the calling object precedes the argument in the list of values, and will return 0 if the calling object equals the argument, and will return a positive value if the argument precedes the calling object. So to kind of make sense of this, look at the example, workday.tuesday compared to workday.thursday will return a negative value because Tuesday is technically 2 days before that of Thursday. Public enumerated array types returns an array whose elements are the values of the enumerated type in the order in which they are listed in the definition of the enumerated class type. So for an example, look at the enum values demo, and that would be this right here. All right, and what it is, this array is filled with first Monday, then Tuesday, Wednesday, Thursday, and Friday. Very much, it takes where this curly bracket is to that curly bracket and substitutes it in here for that array. And lastly, public static enumerated type value of string name returns the enumerated type value with a specified name. The string name must be an exact match So in our example, workday.value of Thursday returns workday.Thursday. All right, quick tip for you. Enumerated types in switch statements. You can use enumerated types to control a switch statement. In other words, the type of the controlling expression in a switch statement can be an enumerated type. This is, of course, illustrated in a new switch demo. Notice that also the case labels must be unqualified names, so such as vanilla, not flavor.vanilla. So when we look at the switch demo here, of course, you can see we have flavors vanilla, chocolate, strawberry. All right, and you'll notice here in the cases, you have case vanilla, case chocolate. It's not flavor.vanilla or not flavor.chocolate, even though here we see flavor of value, right? Because even though the name is flavor, it's not how we're going to be using the cases. This program uses the static method value of to convert an input string to a value of the enumerated type. So for example, flavor.value of strawberry returns flavor.strawberry. You'll note that the program changes the input to all uppercase before giving its argument to the method value of. And you can see that happens right here. Answer equals answer.to uppercase. The method value of requires an exact match, which is the reason why we need the case conversion. An invocation of flavor.value of vanilla will end your program with an error message. You must use vanilla to match the exact spelling, including upper versus lowercase in the value of flavor. At this point, you may wonder what's the difference between therefore strawberry and flavor.strawberry and how to tell which one to use in a given situation. Well, the value of the enumerated type is strawberry. We write flavor.strawberry to say we mean strawberry as defined in flavor as opposed to strawberry as defined in some other type, such as in a berry, strawberry, blueberry, raspberry. A single program with both definitions, that of flavor and berry, could use both flavor.strawberry and berry.strawberry. So when can you use strawberry instead of flavor.strawberry? Well, the approximate answer is when there's enough context in the compiler to know strawberry means strawberry as defined in the type flavor. For example, in a switch statement, if the type of the controlling expression is flavor, then strawberry can only mean flavor.strawberry. This rule will help when remembering when to use strawberry and when to use flavor.strawberry. But sometimes you may have to check a reference or try the two possibilities out and see which one or ones the compiler will actually accept. So if you're not sure, just kind of try it out a little bit. All right, and that's going to wrap up our notes for today, folks. So until next time.